Welcome to grade 11 college math, and we're in unit 4 of trigonometry, and this is lesson 3, the sine law in acute triangles. Now, if you're entering this course coming from the grade 10 academic course, you will have would have learned sine law. If you're coming in from the grade 10 applied, you would not have seen sine law yet. So either it's a good review or it's a brand new concept that we're learning here. All right, what do we mean by acute? Well, acute means non-right angle triangles. So each angle is less than 90 degrees. Okay, so we're going to investigate here. So for each acute triangle, so far in this unit, we've used trigonometry to solve right angle triangles. What about non-right angle triangles called acute triangles? Well, let's do an investigation. For each acute triangle below, use a protractor to measure angles A, B, and C to the nearest degree. Use a ruler to measure the sides A, B, and C to 1 decimal. Record measurements in the tables and use your calculator to complete the ratios. Round your ratios calculations to 1 decimal place. So I went ahead and from your printed sheet, I went ahead and did these measurements. So I'm just going to give them to you. So angle A, we have 16 degrees. Angle B ended up being 86 degrees. Angle C was 78 degrees. Side A, now we can write these in, 16 degrees. B is 86 degrees. And C was 78 degrees. Okay, side A is over here. Side B is down here. Side C. And I measured side A as 1.6. Side B as 5.8. And side C as 5.7. Now, if we were to use these, the side over the angle with a trig function, we would get these. So what would I get? I would get A is 1.6 divided by sine 16. B would be 5.8 divided by sine 86. And C would be 5.7 sine over 78. Don't forget degree symbols. So let's try each of those over on the calculator. So here's the Desmos calculator. So 1.6 divided by sine 16. I get 5.8. Next, let's try 5.8 divided by, I think it's just a coincidence that it's 5.8 again, but sine 86. And what do we get? We get 5.8 again. Okay. All right, let's try one more. 5.7 divided by sine 78. And it doesn't, you know what I did? I typed that in myself that time and it didn't like it. So it wants you to use the function on buttons. Sine 78. We get 5.8 again. This is exactly what we wanted to happen. Okay, so the fact is that our ratio, right, the ratios are equal. So the ratio of angle to side is equal at every combination. That's good. That means it's reliable. Okay, let's try the next one. Side A, side B, side C. And again, I measured them on the printout of the sheet, and I got angle A was 71. Angle B I had as 35. Angle C I had as 74. Okay. In measuring the side lengths, again, depending on a photocopier or what printer you use, that could also change, but on the sheet I had was 4.3. B I had as 2.6. And C I had as 4.4. Okay, we won't write all the information in this box. Let's just go ahead and do the first one. So the first one's going to be, we're now going to see if it matters if we invert, remember the inverse? Invert our side and our angle combination. Here we had side over angle. Here we're doing angle over side. So let's do sine of A. A was, of course, 71. Angle A divided by side A is 4.3. We get a ratio of 0.2. I think it told us earlier to go to 1 decimal place. Okay, so let's try the next one. Sine of B. Now B was 35. I'm going to divide that by side B at 2.6. Okay, so we're also going to get 0.2. Well, guess what's happening here? Same thing. Sine of C. C was 74. Now, why are we getting slightly different decimals? Because my measurements might have been a little rounded, okay? Oh, we forgot to divide by side C is 4.4. We would also round that to 0.2. So equal ratios again. All right, so what does this tell us? What do you notice about the ratios for each triangle? Well, for each triangle, the ratios are all the same. The ratios are all the same. If I write too quickly, it seems to skip and then it makes it messy. So I have to write slowly. All right, here we go. So we actually have a law, the sine law. It allows us to find the length of sides of measurement and measurement of angles in oblique triangles. Oblique is just another word for acute, right? We used acute earlier. They have no right angle. So what here is in the box, whenever we have an important equation, we always use a box. So pick an important color like red. I'll say A over sine A is equal to B over sine B is equal to C over sine C. Or it could be represented as the inverse. Sine. Now when I say inverse, I don't mean second function sine. It's just flipped. Sine B over side B. Sine of angle C over side C. Okay, so what do we notice? Well, we use this one. For a side. So why? Because the side's already on top. So it's easier to isolate your variable when you use one that's already in the numerator position, in the top position. We use this one. For an angle. Okay, because again, the angle, the sine A, sine B, sine C are on the top. So when we cross multiply, we'll have less moving around to do. But we'll show you examples of each. So, all right, here I'll pause to type in the next. Okay, I've gone ahead and typed in what we need to know. So what information must be given in a triangle in order to use the sine law to solve it? Well, you need to set up one complete ratio. So in other words, you'll need at least, let's say a combination of A and side A and angle A. Okay, so you'll need at least a given angle and the opposing side. And then you'll have an incomplete combination or combo of either the A or the C, whichever one's missing. So you'll be missing either the side or the angle, but as long as you have one. So you'll have a complete combination and an incomplete combination. Okay, to solve a triangle means to find all angles and all side lengths. This is important because sometimes you just are left with a question that says, solve this triangle. And it doesn't really specify what things you have to do. So in other words, when you get that, now you'll know, just solve all the missing angles and all the missing sides. Okay, now let's take up some examples. Okay, we want to, number one, we want to find the measure of C to the nearest tenth of a degree. So in other words, I want angle C, so I will use ratio C, sine C over C. Now remember, we said we're looking for an angle, so we're going to put the sine C on top and the side C on the bottom. So now we want to follow these steps. So step one, set up the ratios. Number two, substitute. 3, solve. So let's look at which ones we know. We are missing C. That's a question mark. We have C. Side C. We have B, and we know side B. So there's our complete set. We have a complete set in B and B. We don't know anything about A, and we don't need to know anything about A. We're just going to ignore A. So we're going to ignore A. Okay. And we're going to use the given ratio of sine B over side B, right? So again, we want to have the sine B on top and the side B on the bottom. So now we set up the ratio. So we're going to use, so step one, we're going to use sine C over C, because that's the one we're looking for up here, equals sine B over B. Now we can never use, we're not going to use all three. So let's go back again and look at our equation. Our equation looks like this. These are all equal to each other, but we only really use one. So in this case, we're using sine B and sine C. There's no need to write out A, and you can't solve anything if you have three things equal to each other. So you just focus on the two that you can use. And we are looking for C, and we know the information for B. So those are the two we choose. Okay, so step two, we start to substitute. Well, I don't know sine C, so I keep it as that. But I do know side of C, and it's 40. I know side B, so angle B is 55 degrees. And side B is 55 units. We don't know the measurement there. We're going to cross multiply. And again, when we put something cross multiply, we're going to put it at the front of the sign. So we're going to have sine C equals 40 times sine 55, all divided by 55. Now, you're going to rely on your calculator here. And we're also going to, at this step, switch to angles. Now we're going to switch to looking for the angle. We're going to put all of this in to sine, second function. We're going to put this very same thing in here. 40 sine 55 divided by 55. And put that all into the calculator. It's better if we can keep it all in the calculator. We'll get a more accurate result. 40. What you might want to do here is do a double bracket. 40 sine 55. Close that bracket. Now divide 5 and then close your bracket. Do what we want. Does it have two brackets? That doesn't make any change. Okay, so this is all right. So we are going to get a tenth of a degree. So sine, our angle C is now 36.56. So 0.56 will take 0.6 degrees. All right, good. So we found our missing angle. Next. Now, they're throwing us a bit of a curveball. I want side E, but we never talked about E's. So you can bend the rules a bit, and you can adapt your sine combinations, your sine law combinations, to write new variables. So in this case, we'll use sine E. Okay? It doesn't matter. We're just going to look for the other combination. So what combinations do we know? Well, we know E, and we're looking for E. So there's the incomplete combination. And we have F, but we don't know this F. We're left with a bit of a problem now. Now we have D, but we don't know the angle D. What can we do to find the angle of D? We're not lost here. Okay, so first, find angle D so that we have a complete set for D. Okay, so, well, angle D is equal to 180 minus the 49 right here and minus the 72 right here. That's going to leave us with an angle D of, I'll do the math here. Well, I can do it in my head a bit. 59 degrees. So now we know 59 degrees. And now we have a complete combination for D, the D combination. So step 1, set up your things. So we're looking for side E, so it goes on top. And we know sine of angle E. We put D because we want to match the side with the side, and then the angles with the angles. So let's do this now. E is still unknown. The sine of angle E is 49 degrees. The D we know is 57, all over sine 59 degrees. Okay, we're going to cross multiply. So in this time, when we do that, this is coming up. Now put it after the 57. Okay, it's going to work out better if you do that. So I have E equals 57 sine 49 all over sine 59. Now we're going to change. Now, no need to change to second functions here. Okay, we're going to leave it as is. We're going to find out what the side length of this will be. So come over to the calculator. 57. Actually, you just make a bracket. Okay, because the bracket's going to contain it all. Okay, sine 49. Bracket, you need to now close that bracket. Now it's going to interpret that as all over sine 59. But you got to be careful using your brackets. You have to do it properly. Okay, so what we're saying is like this and this is the outside bracket. This little bracket is just to do with the 49. And that tells it to do all of that divided by the next step. So I get, we get a side length of, to the nearest tenth, 50.18. Well, that turns to 2. And we were talking about meters because look at the 57 had a meter there. All right. Well, actually, therefore, side E is 50.2 meters. All right, let's do one more. This one's going to be quite an ordeal here that we're going to work through step by step. Okay, it's just telling us to solve the triangle ABC, which means all right, so solve means to find all unknown angles and sides. The other thing they don't do for us is give us the triangle. So we have to draw one up. So I usually just draw an acute triangle and I won't worry about the angles too much. My angles might be completely off and not make any sense. But then again, I label them A, B, C. Doesn't really matter what order, but usually left to right kind of thing, clockwise. That's just me. All right, now what do we know about this? So we know it's called ABC, so we've done that. We know that we have angle B. Angle B is 57. Okay, so we did that. We know that side A is 17. We know that side B is 18. Side C is unknown. Okay, angle A and angle C are unknown. So the steps to follow this, to solve this, will be, first, find, which angle should we find because we know more about it? Well, look, we have nothing about C, so that's not going to help us at all. But we do have A side, and we then can use that to help us solve angle A. So let's make that the first thing we do. Angle A, find angle A using sine law. So we're just sort of mapping out. Remember, I always say the setup is the most important thing here. Setting up your strategy. Once we know angle A and side A, we can use the sum. Use sum of angles. Right? That's when it's 180 degrees, right? In the triangle to get the other missing angle, which would be angle C. Okay, so if we know A, we know B, we can easily find out C because of the 180 degrees. Third step, well, find side C, because it's still unknown, using the sine law again. Because now we'll know two combinations. We'll know the A combination and the B combination. We can use either one. I tend to use the one that was given from the start. Right? We were given B right from the start, so I'll probably use B again. All right, so let's try this out. Our first step, we said we were going to find sine A over A equals, now the combination we know are the B's. We know our B combination. So sine A over A is 17 from our diagram, or the given information up here. Sine B, well, our angle is 57 and B is 18. We're going to cross multiply the 17 to in front of the sine. Sine A equals 17 sine 57 over 18. We're going to change that to look for an angle by using second function and a bracket. 17 sine 57 all over 18. Let's try it on our calculator over here. We're going to go second function, bracket, 17 sine 57. And actually, it's since we have a bracket started, we need to bracket it. And then look how that does that. So it includes it all over that. And we need 18. And don't forget over here to close your bracket. All right, so our angle A is 52.4. We'll round it to one decimal place. That's what most of the things we've been doing. Okay, step 2, over here, use the sum of angles. So angle C is 180 minus 57 minus 52.4. Angle C equals, okay, so 180 minus 57 minus 2.4 equals 70.6. 70.6. All right. I don't have a lot of room over here, so let me, well, actually, we can shift it a bit. All right, let's just change colors here so that we're not getting too much blending of our work. So step 3, we planned out our game plan and we're sticking to it. So step 3, we're now looking for C, side C. So we make that the top variable over sine C. And let's go back. I mean, you could use your numbers for A, but we had to round it a little bit there. And I don't know, I just found, let's go back to the originals. We were given B, so let's go back to using what we were given. Then you'll always have more accurate numbers. So C is over sine, and what was our angle for C? 70.6. C is sine 70.6 degrees, and our B was 18. Right from the beginning we knew that. Our sine of B is 57. Okay, we are going to cross multiply this all the way up to the back here behind the 18. C equals 18 sine 70.6. Don't forget your degree symbol. I've been forgetting it quite often. 57 degrees. And we can punch this into the calculator. 18. Again, you might bracket that top just so that you don't want that to get confused with the 70. So 18 sine 70.6 bracket, and then divide. So see how that puts it all together. And then we need sine 57. This is a side length, 20.2 centimeters in this case. So there you go. Okay, then we can make a therefore statement at the end. We'll say therefore angle A is 52.4 degrees. Angle B is 70.6 degrees. And we also needed to find side C is 20.2 centimeters. All right. That finishes up our lesson. So you know the sine law now and how to use it. So make sure you practice the homework, and we'll see you next lesson when we do cosine law.